go. Okay, for today, what we are up to is practicing that deal where we draw a line, shade underneath it that is called graphing inequalities. Do you get that if I did a couple of those and then shaded this way and then remembered that, oh, it can't be negative because I'm making widgets and they can't be negative widgets? Then do you get that what I have left there, that like overlapped area that isn't negative? That's called the feasible region. That's what we did yesterday. If you're like, what are you talking about? You probably weren't here yesterday. In which case, you should go watch the video that I recorded yesterday, because I'm not going to make all these guys go relearn it. And I am going to give you a lot of time to do that today, where you could go back and watch the video if you were gone yesterday and missed that. Okay? So if you have your headphones, you can even just do that right here in class. All right, so we're going to just spend a few more minutes talking about it, reviewing it, and then you're going to have a lot of time to finish yesterday's homework, which is the same exact homework I'm not even assigning anymore. All I'm saying is if you didn't finish it, you got some time to finish it. So it's an easy review day. All right, that's a corner. Mark my words. Those are going to be the answers to the toughest questions. Okay, the vertices of the feasible region. There's 4 of them. The almost never answer is 0, 0. 0, 0 is probably not it. So it's probably that, or that will answer these questions. Okay, so knowing what they are, they're called vertices of the feasible region, is important. All right, next thing. Let's just see if you remember how to graph a couple greats, latest greatests. What if I had x is less than or equal to 3? Graph that. What? There's no y. Well, it's okay. Still graph it. If you know which way the line goes. I always think of these as being kind of counterintuitive. Like I think, where's the x-axis? And it's not like that. Do you get it's like that? And then which way should I shade, though? Because that's the whole less than means shade it. Which way? Left. Do you have to take out the highlighter and make everything that color? No. In fact, I'm really disapproving, or whatever the right word for that would be, of the kids that go like this on all their questions and then try to overlap, because we're going to have like 4 different colors that are all going to overlap, and you're going to get so confused by the end of what the overlapped color is. My opinion, best way to do these is you just shade a little bit on one side of the line. Like here, I might do like that. There, I shaded to the left side of the line. All right, would you please try to graph this one? I'm going to make it greater than or equal to 2x minus 4. First of all, this is reminding you how to graph basic lines, and then how to shade them. I love that somebody was doing the XY chart. That is awesome. If you ever get stuck, that is a great place to go. Go with a bunch of dots, connect the dots. You had a straight line, you're doing it right. Now, if you forgot, that's the slope. Slope's 2. Y-intercept's -4. So actually, this time it might be easier. Just go down to -4 and have a slope of 2. And which way should I shade, sir?
Up and to the left.
So above the line or below the line? Above the line. There you go. Raise your hand if you had that one right. Okay, good. Now leave that one on the screen. And we're going to graph another one over the top of it and see where the feasible region is, the place where they overlap, and isn't negative. Because in the real world, if you're out manufacturing things, time can't be negative. Like, that's going back in time. That'd be awesome, but you can't do it. And widgets that you're making can't be negative. All right, so you ready? Graph this on the same graph, make them overlap, and find the feasible region when y is less than or equal to 4x plus 3. Wait, stop. I just realized I wanted that line to go the other way because this isn't going to make a very nice feasible region. Not saying it couldn't work. If you graphed this and then shaded this way, you were doing it right. But I apologize. Our feasible region is going to be really weird looking and it won't have like an end on it. So what I wanted to do is put in a negative. Would you please make it negative 4x plus 3? That'll make the slope go the other way. And it'll give us a much more reasonable feasible region. Negative 4x plus 3. Less than means shade underneath it. Final answer, the feasible region. I'm going to make it in blue. It'll be right there. Some of you are like, why didn't you keep going down here? Because then you're allowing numbers beneath this line, which means that you're allowing negatives, things that are below the x-axis, which would be y equals 0. So I can't allow those, so I'm going to undo. And I want to just do that much. Because imagine if there was a line here where you were saying to shade above it, and a line here, oh, I missed. A line here, I'm saying shade to the right of it. It's kind of like that. All right, so that blue squiggled, darkened in region, that is your feasible region. And what did I say was pretty much always going to be the answers when we're done with this unit? Vertices. So it'll be there, or there, and I said the answer is pretty much never 0, 0. Because 0, 0 doesn't make much sense in the real world. That means that you don't do anything. So then why is your company or your grades or whatever this is about, why is that even in business if you're going to do nothing? Usually this is how many you should sell to maximize the profit, or how many you should sell to minimize your costs. Like you want to make it cheap as possible, but so the corners of the feasible region is what it's all about. All right, last but not least, I suggested yesterday that you learn how to write equations, and so we're just going to do one like that. In the real world, you could use this, really, seriously. So imagine for a moment you're going to rent a carpet stretcher. What the heck would you do that for? You want to do the carpeting yourself because you found a piece of carpeting really cheap at like Home Depot, and you're trying to save some money, and you're doing a DIY, like you're making a little tiny house in your backyard. Maybe it's you. You got a little shed in the backyard, and you're like, I'm going to make this really cool, like a little tiny house. So you rent a carpet stretcher. There's one store that rents it for $50 all day. The other store, I'll change colors, charges only $20 up front. That means right when you rent it, you immediately owe them $20. Even if you only kept it for 5 minutes, you got to pay $20. Plus $5 per hour after that. Well, let's call this black one store A. Let's call this blue one store B. And a typical ACT question would be, and test from your next test in this class also, would be write 2 equations, one for each store, and then solve the system of equations to find out where the at what amount of hours they would charge the same thing. There's some magical number of hours where it's going to cost $50 either way. Know what I mean? Store B, there'd be a magical number of hours where it'd be the same price. So write an equation for the black one, write an equation for the blue one, and then solve the system of equations. This is not question 1, 2, 3, 4, 5, 6, or 7 of the ACT. This is one of the medium hard ones. You should be able to do it. If you're like, I don't even know where to start. Well, the top one's y equals 50. What's the equation for the blue one? 5x plus 20. Now solve that system. There's two different ways to solve, actually three. You could graph it, you could use substitution, you could use elimination. Any of those work. Find the solution to the system. You find the spot where they're both the same. I'm going to pause while you give that a try. All right, I'm hearing a lot of people have already got the answers, so I'm going to go show you that 50 goes there. Why? It's called substitution. Y is 50, so I'm going to put a 50 here. So 50 equals 5x plus 20, and then from there, super easy. Subtract 20, 30 equals 5x. So therefore, x must be 6. Now, in the context of this question, that means 6 hours is magical because at that moment, it would cost you the same in either store. So that means you don't care which store you go to. But a good follow-up question in the real world is, what if you have a short job? Which store do you go to? Like you don't need it for many hours.
B.
Store B. Because up to 6 hours, this will be the cheaper way to go. At 6 hours exactly, you don't care which store you go to. What if it's more than 6 hours? Then you'd want store A because you already paid 50 and it's good all day. So might as well, if it's like a 12-hour job, then store A is better. Okay? That's typical of this unit, and it's typical on the ACT. And that's enough practice for today. Your assignment, if you didn't already catch it, is a worksheet. And I had you skip certain problems. You're going to know which problems to skip by watching the video, because I was much more detailed yesterday on how to actually do these. Okay? If you really want, you can always ask a friend which ones we skipped yesterday if they can show you which ones they crossed off. So, all right, your homework is that same worksheet from yesterday. I'm not adding any more to it. You can just, the same problems I assigned before. And that's all I got for you for today.
Can I go to the bathroom?
Yes, you may. Yes, you may. April 3rd.